Guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement. So it says, given the root of a binary tree, right? It says return an array of the largest value in each row of the tree, right? So pretty much what they're saying, guys, I'm saying to return the maximum value, right, for every row, right? For the first row, we can see 1 is the maximum value since it's by itself, right? And then 3, it's the maximum value for this level because 3 is greater than 2. And then 9 is the maximum value for this level because there's no numbers greater than 9, right? So that's why we return those numbers as the result. What I'm saying. So since so whenever guys I think of things like processing things level by level, everything that the one thing that comes to mind, right, is using a breadth search. I'm saying, so breadth search is going to help us and easily be able to process nodes level by level and check it, right? So pretty much, this is easy check now. As we visit the nodes, right, or the levels, we just have this maximum variable, guys. I'm saying that's going to keep track of the maximum variable that we've seen, right? And then we just loop through all the nodes for that level, and then after we process all the nodes for that level, we just add the maximum that we saw, right? We just add it to the output list. And then we're pretty good shape, right? This is the approach that I would go with. I'm saying, and this is a very good approach, actually. I'm saying, so let me just show you how it works. You just go through a couple quick examples, right? I'm saying, so we have this. We got a maximum variable, right? That's for every row, right? So maximum is gonna be a very small number. I'm saying, like we have 2 to the power of 31. I'm saying. That's what he says right there. I'm saying. So the values are going to be like that, right? So now, okay. So now that we have that guy, I'm saying, will be also for every row, right? So we need to, so we got to put it in some kind of so we got the maximum of every row in some kind of output list. I'm saying. So we do the same thing, guys. We will loop through. So we check it 1 or a very small number, right? 1 is obviously bigger, so max will get updated with the maximum, right? So after we're done processing all the nodes for that level, we add the maximum value to it, right? And then now it gets restarted again, right? -2, right? It goes back to that very small number, right? And then we check those 3. So we're at this level now, right? So as we're going to right, we're gonna be adding the nodes, right, to like a cube, right? But this will come later. I'm saying, so we're at this level now. We check 3 is bigger, boom. 3 gets updated, max gets updated, right? And then we go to 2, right? 2 is now bigger than 3, so the max doesn't get updated. I'm saying, so after we process all the nodes for that level, we just add it to we just add that maximum value to that thing, right? We do the same thing there, right? We would do, so initially it would be a very small number, right? And then we visit 5. 5 is the maximum we've seen so far for that row, right? And then we go again. We see 3. It doesn't get updated because 3 is smaller and 5 is bigger, so it stays the same. And then once we're encountering 9, right, we visit 9. It gets updated, and then we process all the nodes for that level, and then we just add it to the output list. I'm saying, so pretty simple. So this is how we're gonna go, and doing things level by level, guys. So hopefully you guys were able to follow this thought process. Let's just go with the implementation. I think it'll make a lot more sense, guys. I'm saying. So what we're gonna do, right? We need to have our output list. I'm saying, so it's gonna be integers, right? Integer res new array list, right? So it's gonna store our result. I'm saying. So now we check edge case, right? If the root is null, right? We return the root, right? Return null. You consider root, but I make it clear to you guys. No, I'm saying. Then at null, we need to return the result actually because we're going to return empty list. I'm saying. So after we do that, guys, we do tree node, right? So we're gonna have a queue of tree nodes, right? Queue of tree nodes. We're gonna have the linked list implementation of that. I'm saying. So now that we have that, guys, I'm saying the next thing that we're going to do, we need to add it to the output list. I'm saying, no. We need to add the root to the queue, right? Because we're gonna start processing the nodes. You know what I'm saying, and this is yeah, it's like the template for what I'm saying when we're doing breadth search, guy. I'm saying, so we gotta keep processing the nodes, right? While the queue is not empty. You know what I'm saying, while the queue is not empty, we're gonna process the nodes. You know what I'm saying, so so what the next the thing that we're gonna do, right? So we gotta take a snapshot of the size of the queue. You know what I'm saying, I'm gonna tell you guys exactly why we do that. We do that, guys, so we can keep track of how many nodes belong to a particular level, right? Because, you know, we're gonna keep adding new nodes as we go as well, as we visit the nodes, right? We take the size to know how many, we take a snapshot, right, to know how many nodes belong to that particular level, right? So we know when we first start, right, we add one, right? For that level, we know there's only one node to be processed for that level, you know what I'm saying? So that when we add 3 and 2 to the queue, right, we don't keep just looping through nodes and nodes, right? We stop and then we start over at the beginning of the while loop, right? So that we simulate going on to the next level, guys. What I'm saying, this is how it works. So we get the size, right? Get the size, and we know that for this level, we need gonna process at most one node, right? So just like when we get to that level, right, we get a snapshot of the queue size, and then that's gonna help us. You know, we add 5 and 3 is 9, right? Now we know, even though we added those nodes, right, we know that for that level, there's only 2 nodes that belong to that level. So we're only gonna process 2 nodes. Then we're gonna start over to simulate going to the next level, and then now we process that node. I'm saying, so that's why the size variables are important in that thing, right? So now what we're gonna end up doing, guys, I'm saying, we're gonna have this for loop, right? That's gonna help us in controlling how many nodes that we need to process for a particular level. Say while the row is less, I is less than the size, right? We do I plus plus, right? And then what we do, right? We get the node out of the queue, right? So we do queue that pull, right? So all right, so thank you. Let me get you out. So now I'm gonna process you, right? So we do. We also need to have the maximum variable, guys. I'm saying. So the maximum is gonna be a very small number, that, like we talked about, right? And we get that from the integer class. What I'm saying. So we get the value, right? So we do maximum value is gonna be math.max, right? Of the current max, or right the current value that we're at right now, right? Okay, so after we do that, guys, you know, we need to check, right? Does it have any is there any children, right? So we check if it has a left child. So we check if node that left is not null, right? So that means there's a child, right? We would add it to the queue. I'm saying, so we add node that left to the queue. You know what I'm saying, you know, we also likewise we check does node that right, right? Is it not null? What I'm saying, if node that right is not null, we add it to the queue as well. I'm saying, yeah, that's a queue. So after we add it, guys, what I'm saying, and we so we add that. So we do that for every node, right? And then after we process all the nodes for a particular level, we add the maximum to the output. You know what I'm saying, and then after we do that, we done visit every node. We just return the res, right, as that has the answers, right? So let's just go. So just go through an example real quick, right? Quick dry run. So we add a 1 to the queue, right? So now that's how we start, right? At queue, and then we're gonna process the nodes. We're gonna be in this while loop until we process all the nodes, right? So until the queue is not empty, we're gonna keep we're gonna be inside of this while loop. So we get the snapshot of the size, right? So we know the size initially is 1, right? So we get that, and then we check the maximum value, very small number, and we loop through. We get 1 out of the queue, right? And then we check between very small number or 1, right? Enter that main value or 1. 1 is bigger, so we keep that, right? So 1 max gets updated to 1, right? And then we left is not null, we add left, right? Right is not null, we add right, which we add 3 and 2, boom, to the queue, boom. And then there's no more node to process for that level, right? Since we said that there's only 1 node, so I went up to 1, so now we exit out the for loop and we add the maximum value for that level. And likewise, we go into the next level, right? So now we go into the top of the while loop again, right? And then we get a snapshot of the size, right? So now there's only 2 numbers in the queue, right? So we get a snapshot, right? Before we start adding new numbers, right? We get a snapshot, right? The queue said, so for this level, there will be at most 2 nodes, right? So we get the size, and then we do the same thing, maxi update it back to being a very small number, enter that min value. We just keep doing that. And we do node that left is not null. we return. Note that left is not null, right? We just keep doing that. Now, note that left's not null. We add it to the queue, and then we keep doing that, right? Over and over, guys. So hopefully you guys are able to follow the thought process, right? So let's just check if we pass the small test cases, guys. You know what I'm saying? So yeah, nice. Let's see if we pass all the test cases. Awesome, guys. We're past all the test cases, guys. And I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys on the next one.